Look, over the last few decades, trillions of dollars and literally billions of man-hours have been poured into fundamentally re-engineering the physical world. And it's happening at a pace unlike anything we've seen in modern history. Welcome to This Explainer. Today, we're going to unpack a comprehensive list of 50 massive contributions made by Chinese engineers over recent decades. If you really want to understand the sheer scale of global human infrastructure and how rapidly our physical reality is being rewritten, you have to look at the data. We're going to explore what is basically a masterclass in scale, looking at how engineering touches absolutely everything around us.
All right, let's just start with this simple, frankly staggering number, 50. We aren't talking about 50 minor tweaks or, iterative software updates. We're looking at 50 distinct, world-altering engineering achievements that span multiple, highly complex disciplines. From civil engineering to quantum mechanics, this list represents a massive, coordinated push to completely rethink how human beings interact with their environment, how we move, how we generate power, and how we compute data.
Which brings us to a really fascinating question, right? How exactly do you engineer everything from the crushing bottom of the ocean all the way to the dusty surface of Mars? To understand how these 50 seemingly disconnected innovations actually form one giant, unified story of rapid technological evolution, we need to look at how they shape the world around us. Because when you step back and look at the raw data, a very clear, deliberate pattern emerges.
So, here's our roadmap. We'll start with shaping the physical world, then move into revolutionizing movement and transit, followed by powering the future, next-gen tech and manufacturing, and finally, reaching beyond Earth.
All right, Section 1, Shaping the Physical World, Engineering the Earth.
Just look at this contrast for a second. On one hand, you've got desert highway construction, literally engineering a stable, durable path right through shifting sand dunes that can bake at well over 150 degrees Fahrenheit. Then, on the complete opposite end of the spectrum, you've got sea-crossing bridge construction, where they're sinking massive steel and concrete pylons hundreds of feet into unpredictable, highly corrosive ocean depths. It just shows an engineering adaptability that flat-out refuses to be limited by geography.
Now, these rapid-fire innovations are what directly dictate how we'll safely and sustainably live in future cities. I mean, we're looking at mega hydropower dams and advanced tunnel boring tech that literally carves right through solid mountains. And then there's the geological audacity of artificial island construction. But it's not just about dominating nature, it's about adapting to it. Take innovations like sponge cities. These are urban areas engineered with advanced permeable surfaces to literally soak up massive floods like a giant sponge. Combine that with modern earthquake-resistant designs and lightning-fast prefabricated modular construction, and it all points to cities that are far more resilient. This matters immensely because it ensures our future habitats can actually survive the elements.
Moving right along to Section 2, Revolutionizing Movement and Transit, the World in Motion. Think about the extreme physical demands here. You're pushing the absolute boundaries of altitude with railway engineering in thin, freezing mountain air, while at the exact same time, you're engineering deep-water offshore oil and gas platforms that plunge down to the crushing pressures of the ocean floor. The sheer engineering bandwidth you need to pull off both of these extremes simultaneously, it is, frankly, mind-bending. And just notice the sheer scale of momentum here. We're talking about highly automated, massive capacity systems. Take the deployment of the world's largest high-speed rail network, or maglev transportation. If you don't know, maglev uses magnetic levitation to smoothly propel trains at aircraft-like speeds, and they never even physically touch the tracks. It completely revolutionizes how billions of people travel. Add in automated container port engineering, sprawling metro networks, intelligent traffic systems, and advanced shipbuilding. This isn't just about getting from point A to point B anymore. It's about optimizing the entire global supply chain, which basically means the goods you rely on arrive at your doorstep faster than ever before.
Okay, Section 3, Powering the Future, Energy and Resources.
Now, all of that infrastructure needs power, right? Here is an incredibly diversified energy portfolio. Under renewables, you've got huge investments in solar photovoltaic manufacturing equipment and wind turbine engineering. Parallel to that, there's heavy construction in nuclear reactors. But the real magic trick, the absolute glue holding all this together, is the grid infrastructure. Ultra-high voltage, or UHV, power transmission is what allows you to generate massive amounts of energy in a super remote location and transport it thousands of miles to dense urban centers with virtually zero loss. It's literally the circulatory system for modern supereconomy. Which brings us to Section 4, Next-Gen Tech and Manufacturing, the Digital Brain. This rapid barrage of innovation highlights a massive shift toward pure precision and automation. We're looking at industrial robotics and precision CNC machine engineering,
which basically uses advanced computer programming to control cutting and machining down to a microscopic level. This foundational hardware is what lets you scale up electric vehicle production and the lithium-ion batteries that power them. Throw in drone manufacturing and fully automated warehouse logistics, and the result? A global supply chain that is increasingly untouched by human hands. And all of this is powered by AI computing hardware, supercomputers, and semiconductor manufacturing equipment. This is the digital architecture of tomorrow. Tied together by huge fiber optic networks and massive 5G telecommunications deployment, it makes sure data moves just as fast as those high-speed trains we talked about earlier. There's even the deployment of quantum communication infrastructure, using the fundamental laws of physics to create theoretically unhackable networks. This represents the future of how every single one of us will process information and communicate securely on a daily basis.
Finally, we hit Section 5, Reaching Beyond Earth, Aerospace Expansion.
It's kind of the ultimate question, isn't it? Once you've engineered the Earth, from sea-crossing bridges all the way to supercomputers, where do you go next? Well, that exact same engineering ambition inevitably points upward. It completely breaks the bounds of our atmosphere, applying those same principles of precision, power, and transit to the vacuum of space.
You can actually see a very clear, methodical progression outward here. Step 1 secures Earth's orbit with the Beidou satellite navigation system and, of course, vital research into reusable rocket technology. Then, Step 2 pushes further out to our closest neighbor with advanced lunar exploration spacecraft engineering. And finally, Step 3 takes the ultimate leap to another planet entirely, with highly sophisticated Mars rover engineering. It's a step-by-step expansion of human presence and capability in the solar system. So what we've seen throughout this explainer isn't just some random list of projects. It's a comprehensive, deeply interconnected web of human achievement. When you take a step back and look at how ultra-high voltage grids power the industrial robotics, which then manufacture the batteries that power the drones, which are guided by the satellite networks up in orbit, you start to realize this spans literally every imaginable domain of science and physical labor.
And ultimately, these aren't just pie-in-the-sky concepts on a whiteboard. These 50 contributions reflect areas where Chinese engineers have played significant roles in research, design, construction, manufacturing, and deployment over recent decades. We're talking about decades of profound, tangible deployment that have objectively shifted the landscape of modern global infrastructure.
I want to leave you with this final thought to ponder today. We've just mapped out 50 massive leaps forward that have fundamentally altered our physical and digital world. As these foundational technologies continue to compound, integrate, and evolve at this